All right, this problem is from section 12.3, and it says the population of walleye in northern Minnesota lake is projected to decrease by 10% each year due to overfishing. It's estimated that at the end of the first year, there are 50,000 walleye in the lake. Part A says write a rule for the number of walleye remaining after the nth year. Okay, so it's going to decrease by 10%, which means that 90% are going to remain. And make sure that that makes sense, because a lot of times with the geometric problems, those complements occur, like it goes down by 10%, which means 90% remains, or, you know, vice versa. So I also know it's geometric because it's a ratio. Any percent, of course, is a ratio. And at the end of the first year, I have 50,000 walleye, so there's my first term. So I know it's a geometric sequence. So if I write an explicit rule here, my first term would be the 50,000 walleye, and my ratio is 0.9 because that's how much remains, not 0.1, and raised to the n minus 1. Part B says if the current rate of depletion continues, how many walleye will be in the lake at the end of the 15th year? So I'm going to use my rule and plug in 15 for n. So 15 minus 1, and dump that in your calculator, and you get 11,438, and it's fish, so make sure you round it. You're not going to have part of a fish.